Hello, everyone. I had somebody request for me to do 5.2 problems 6 and 7. So I was going to show y'all that real quick in case you have any questions. I am using my AirPods because my computer will not. Why is that so small? Because my computer audio won't work. Anywho, okay. So on this problem, I went through it, and then if you clear it, I should have cleared it and got a new one. When you're finding the end behavior of a graph, it'd be you're multiplying it all the way out. So since I saw I had x squared and x squared, I know x squared times x squared would be x to the fourth power. Your end behavior is going to be whatever is that very first term when you multiply it all the way out. You do not have to multiply it all the way out to find that because there's no term in front of this. So it's not like I have 3x and 4x. If I had 3x and 4x, it'd be 12x. And then you have to take into account whatever these exponents are. So the end behavior of this is x to the fourth because x squared times x squared equals x to the fourth. Okay, our x-intercepts, this is going to be you're taking both of these factors that they've gave you and setting them equal to 0. And then you'd solve it. So I'd subtract 3 here. So x equals -3. And then here we'd add our 4. So we'd have x equals 4. And then they just want an integer. So we have -3 and 4. But you do not put x equals on them, just -3 and 4. Our y-intercept, you'd put 0 in for x and solve. So I'm going to write y instead of f of x. And then I'd have 0 plus 3 squared times 0 minus 4 squared. So we'd have 3 squared times -4 squared. I don't have much room, which is going to be 9 times 16, which is 144. Determine the zeros of the function and their multiplicity. Use this information to determine whether the graph crosses or touches the x-axis at each x-intercept. So the zeros are the same as your x-intercepts. These are the same thing because the 0 is just where it crosses the x-axis. We solve these for when y is 0. When y is 0 is the same as this. I don't know how to explain that differently. A 0 and an x-intercept are the exact same thing because when f is 0, that is your x-intercept. But multiplicity though, so our multiplicity is whatever it is. So like what power is that factor raised to? So both of ours are 2. So an even power means you're just going to touch the axis. So at these points right here, -3 and 4, since our multiplicity is 2 on both of them, we're just going to, so the lesser 0 multiplicity 2. So the graph of f touches the x-axis at -3 because this is the lesser one. So -3 is first, but both of our multiplicities are 2 on this one. It's blurry. But you fill in right here too. So it touches because it's even. Just think of your linear graph is x to the first power and it crosses. X squared's a parabola, so it touches. And then x cubed, you go across. We did our parent functions the last chapter, so that should be familiar. The greater 0, our greater zeros are 4. One thing I see people do on this is that they put the 4 here instead. The multiplicity is the power that's with it. So squared, and it touches again because it's an even. Even touches odd, crosses, and then the x-axis at 4. Determine the maximum number of turning points of the graph. So on this part, you're going to go back to here, and whatever this power is, so since it behaved like x to the fourth power, you're going to take whatever your highest power is and subtract 1. So power, subtract 1. So 3 is our turning points. So now we have 3 turning points, then we can look at our graph. This one only has 1, 2. This one only has 2. And then this one has 1, 2, 3, and so does this. But our end behavior of our graph is that it's positive. Negative graphs open downwards. This one opens upwards. This is our graph. All right, let's do this one now. So the graph behaves like y at the end values. So we take -2, and then right here we have x squared. And then we'll have this x squared as well. And you multiply those all together. So we're going to have -2 x to the 4th power. I actually worked this one out too, but I didn't print it out till after when I realized what I was having to do. Okay, our x-intercepts, we don't care about this -2 on this part because there's not an x with it. We only care about where x is. So we have x minus 2 equals 0. So we'd add our 2. So one of them is x equals 2. Here we have x squared minus 16 equals 0. So if we moved our 16 over, we have x squared equals 16. So we'd take the square root of both sides. When we do this, we're going to have a positive and a -4. So when I write this one in, I think I just did 2, -4, 4. Sometimes when you get a lot, they tell you to start putting them in order of least to greatest. This one doesn't. So just be sure you separate with commas. Y-intercept, we'll do 0 equals -2 times, well, y equals -2 times 0 subtract 2 squared. Then we'd have 0 squared minus 16. So we're going to have -2 times -2 squared times -16, which is -2 times 4 times -16. I don't remember what 32 times 4 is off the top of my head. 128. And it's positive because a negative times a negative is a positive. But x-intercepts and zeros are the same thing again because you're putting 0 in for y to solve for both of them. So type the answer. It doesn't say to do it in order. Okay. Now then, our smallest real 0 is going to be our -4. I'm writing it here, but they don't want that there yet. Our middle real 0 is 2, and our largest real 0 is 4. Okay. This is the confusing part when we get more of them because then everybody wants to put this value right here in for this. They're talking about multiplicity right here. So our -4 and our 4, since we split them up here, this is the difference of 2 squares. So another way they could have wrote this would have been, can y'all see that? X minus 4 times x plus 4. And on that, the multiplicity on both of those would have been 1. So we'll go through it like you have to. So the smallest real 0, multiplicity 1. So the graph is going to cross at odd, touch it even. And at that point, x equals the -4. That's where that goes. The middle real 0 has a multiplicity. Our 2 was squared. So the multiplicity is 2. It's going to touch at 2. The largest real 0 has a multiplicity of 1 because it's this. And it's going to cross at 4. Okay. The graph has at most blank turning points. So we go back to this -2 x to the 4th power, how our graph behaves at the end. All we care about is this. So we take the power, subtract 1. Y'all, I got pregnancy brain bad. Equals 3. So we have 3 turning points. This one only has 2. This graph only has 2. So then we're looking at both of these. Both of these graphs are negative. But one thing I see when I look at this, I'm looking at the y-intercepts. So our y-intercept is supposed to be 128. This one doesn't even look like it has a positive y-intercept, and 128 is quite large, so I'm going to let y'all see the not scribbled on one as well. So cross, touch, cross, because you have to do the drop down menu for that. I know there's a lot of questions to these, so if y'all have any questions on it, just shoot me an email and we'll figure it out.